All right, guys, so we're finishing up 4.4 today, chapter 4.4. And the first thing we're going to start off with is the factor theorem. Now, there's a lot of this here going on and a lot of stuff here. Now, what it's really boiling down to is whenever we divide something, and we did this with synthetic division, when we divide a polynomial by a monomial or binomial here, and we get a remainder of 0, it means what we divided by was a factor. So we could rewrite it as that x minus k times our quotient, whatever we got. Together, they are factors. And the real part of the remainder theorem is this here. A polynomial f of x has a factor x minus k if and only if its remainder is 0. If the remainder is 0, then it is a factor. If the remainder is 0, then it is a factor of that polynomial. I mean, really, we can relate this back to long division. 4 divided by, let's just say 64. Well, if I do this division, we'd have 1. 24 would be 6. So I know 4 times 16 is a factor of 64, yes? It'd work the same with polynomials. So what we're going to do is, the first thing we're going to do is determine if the factor is if the binomial, the x minus k, is a factor of the polynomial. If it is, awesome. And that's all we're going to do here at first. So are there any questions on this factor theorem so far? So if it has a remainder of 0, it is a factor. So when we look at this first one here, I'm just going to go straight to synthetic division. Because if, after we do synthetic division, if the remainder is 0, then it is a factor. It's a factor of the polynomial. So our numbers going across the top are going to come from this polynomial here. So we'd have 1, 2, and -4, and we would drop the 1. Now, just looking at this here, because our x minus 2 is going to give us the number that goes in the cubbyhole, do any of y'all have a guess, just by looking at it, what number we would use? It is 2. And it's positive. Because when you think about it, when I solve it, x minus 2 equals 0, I'm going to add 2 to both sides, and we plug in positive 2. It's really just taking that number and flipping the sign, isn't it? So we could do that. Any questions on this here so far? Now we can do our steps. So we would do 2 times 1, which would be 2. And then we would add. 2 plus 2 gives me what? 4. And then we would do 2 times 4, which is 8. And -4 plus 8 gives me 4. So is x minus 2 a factor of this polynomial function? No, because we wanted the remainder to be what? 0. No. And that's it. That's all we had to do. We just had to determine whether it was a factor or not. Yeah. Now, it will change about halfway through, and the note sheets are out of order. I'll tell you that right now. So the back of the first page is going to come later. Okay? So we'll skip to page 2. So are we good with this here so far? Oh, missed it. Because example 5, so x plus 5, I think that's the top of the second page. Yep. So again, these first few, we're going to be just determining if it is a factor, if it's a factor. And this is helpful. This is nice, because eventually we'll go over exactly how we can find these factors, methods and ways so that we can find them without them being told to us what they are, or ones we're going to check. Because now I'm not having to go through grouping or our different factoring methods to try to see if we can find it plugging and guessing. Because if I do synthetic division with here the x plus 5, do the synthetic division, it's telling me either yes, it's a factor, or no, it's not. I'm not having to plug in different numbers like we've been doing before. So here we can check this. So across the top, we would have 3 for x to the 4th, 15 for our x cubed, -1 for our x squared. Then what would be next? 0, because we do not have an x to the first or an x term, so we need a 0 there. And then we would have 25. And what number would go in the cubbyhole? It'd be -5. Because the way we would find that would be doing x plus 5 equals 0. And we would subtract 5 from both sides and find x is equal to -5. That's how we would kind of go about finding that value. We set it equal to 0 and solve. All right. So that leads us into our next step where we multiply. So -5 times 3, which is -15, which we put under the 15. -15, or 15 plus -15 would be 0. -5 times 0, 0. -1 plus 0 is -1. -5 times -1 would be 5. 0 plus 5 would give me 5. And lastly, -5 times 5 is -25. So is this a factor? Yes, because we got a remainder of 0. So determine whether this is a factor. Is it a factor? Yes. Yes, it is. Because it gave us a remainder of 0. Since it gave us a remainder of 0, it is a factor. That's it. That's all we have to do for this here. Any questions on this here? Let's do another one. So our numbers across the top would be what? Well, 1. Well, we're going to drop the 1. Now, to figure out what goes in the box, we would solve x minus 3 equal to 0. And we do that by adding 3 to both sides, and we find out that x is equal to 3. Any questions on this here so far? So we'll do our multiplication, 3 times 1, which would give us 3. 9 plus, or 3 plus 6 gives us 9. I was getting ahead of myself. And then we would do 3 times 9, which gives us 27. -12 plus 27 would be 15. So exactly, yes, this would be no. This would be no. Because we have a remainder that is different than 0. Because we need the remainder to be 0 for us to be able to say that this is a factor. Questions on this here? Questions on any of this here so far? We like this here so far? Yes? Yes, if I'm able to find the factors, well, we can do this and just simplify it down as we go, yes? Yeah, we can just keep plugging that in and simplifying the polynomial. Because each time I check a factor, it takes the degree down by 1 each and every single time. So it helps us. It helps us be able to solve these. Let's do one more because I feel like, for the most part, y'all are getting this here. This is not too bad. Not compared to most of the stuff we've been doing in here. So what would the numbers going across the top be? We'd start out with 2, 10, 11, 1, 6. And we drop the 2. Now, what goes in the cubbyhole, we'd really solve x plus 3 is equal to 0. So we'd subtract 3 from both sides. And we get x is equal to negative 3. Now, I really haven't been writing out our multiplication steps, but our first one would be negative 3 times 2, which would be negative 6. And we put it under the 10. And we have 10 plus negative 6, which would be 4. Then we do negative 3 times 4, which is negative 12. 11 plus negative 12 would be negative 1. So we do negative 3 times negative 1, which would give us positive 3. Negative 1 plus 3 is going to be 2. And so lastly, we have negative 3 times 2, which is negative 6. And negative 6 plus 6 is 0. So is this a factor? Yes, this is a factor. Yes, it is a factor. Now, what I'm going to say, and what we're going to kind of discuss briefly for the next minute or so, is when we talked about solving in chapter 3, the last chapter with our quadratics, we were trying to find values of x that would make the function be what? 0, yes? Because we're trying to find values of x that would make the quadratic equal 0. Because that's what we're doing to solve, yes? What does this value of x do for this polynomial function? It makes it equal 0, yes? So what does it mean about negative 3 for this function? It is a solution, isn't it? Because if I plug this into the function, it would make it equal 0. So really, what we're saying with this synthetic division is any solutions for the function will make it equal 0, yes? And not only that, if I were to plug the variables back in, constant, x, x squared, x cubed, I've taken it from a degree 4 down to a degree 3, yes? So if I know another solution, I can take it from a degree 3 down to a degree 2. If I have a third, I can take it down to a degree 1. Just x plus a number, or something times x plus a number. Those are easy to solve, yes? That's why this is nice. Y'all see that there? Because it can take these higher degree polynomial functions, if we can find values, and decrease them and make them easier to work with. So we'll go over more of that on Monday, is when we're going to actually start solving these. We're going to move on to this here because I feel like y'all got the handle of saying either yes, it's a factor, or no, it's not. Now this is the top of the back page, so we're going to do this one, these two on that page, then we're going back to the back of the first page and finishing this up. Now there's a slight difference for this one than we've been doing. So this one here says what? Show that x plus 3 is a factor. So is x plus 3 going to be a factor? Well, yes. What are they telling us to? Well, show that it's true, yes? Because they don't say show us that this is true. if it's not, because they're pretty much telling us this is a factor. Then you what? Factor it completely. Because at this point, we could have some different methods for factoring this here. We could try grouping and other things. But let's use synthetic division first, because it's going to make it easier. Because across the top, we'll have 1 for x to the 4th, 3 for x cubed, 0 for x squared, -1 for x, and -3. We're going to drop the 1. Now what's going to go in the cubby hole? -3. Because when we solve x plus 3, we would subtract 3 from both sides and get x is equal to -3. So let's do our steps. I'm going to move this. Okay, apparently I'm just going to mark on board. Move this over here. So we're going to do our first step, which would be -3 times 1, which is -3. What is 3 plus -3? -3 times 0 is 0, isn't it? 0 plus 0 is 0. -3 times 0 is 0. -1 plus 0 is -1. So now we need to do another multiplication. -3 times -1, which gives me 3. And -3 plus 3 is 0. So it's a factor like we expected it to be, yes? Because it told us it would be. It told us, pretty much it was telling us that we should get a remainder of 0. So let's see what we have. This here is our remainder. This is our constant. This would be our term with x, yes? This next one would be the term with x squared, and then we have x to the 3rd, yes? So, what do I have left over? I have x to the 3rd. Because these are gone, -1, yes? Well, x plus 3, we just showed it was a factor, yes? I mean, we could have been doing these on the last ones. But since it's a factor, I could rewrite it as what we have left over times our beginning factor. Because if I multiply these together, I'm going to get back to this here. We'll get back to that there. Now, is this thing factored completely? Well, the x plus 3 has a degree of 1, yes? So it's done. How about the other one? Well, it has a degree of 3, yes? Difference, so subtraction. It'd be nice if they're a difference of perfect cubes, because if they are, then we have our method that we learned the other day, yes? Can I take the cubed root of x to the 3rd? It would be x. Can I take the cubed root of 1? What times itself 3 times is 1? 1. It's one of the odd numbers that you could actually take any root of it and it'd still be 1. Because the 19th root of 1 is still 1. Because no matter how many times you multiply 1 by itself, it's still 1. So we get this here. So we can do our difference of perfect cubes. We'd still have the x plus 3. 3 spots. 5 spots. Now our signs would be the same, opposite, always end on a positive note. The same, opposite, always end on a positive note. Our a value this time around is going to be x. So here we're going to have x, nothing, then x squared x to the first. Any questions on this here so far? Okay. Nope, that's not going to show up. Let's take this color. Looks good. This here is our b value. So we would have 1, nothing with the x squared, 1, and then 1 squared. Any questions on how we got to this point here? Any questions on any of this here so far? We good with this here? Yes. Now we just need to simplify this, which would be x plus 3. We just have x minus 1. Now x squared is just x squared. 1 times x is going to be plus x, and 1 squared is 1. And we get this here, and we're done. Because we know that the x squared plus x plus 1 will not have any factors. It will not factor lower than that. It's done. Because if I really wanted to, I could use the quadratic formula to solve for it. And those are the kind of solutions we would get. They're not rational and they're not real, so it doesn't work. So this here is as far as we can factor it. And again, the quadratic that comes out of the sum or difference of perfect cubes will never factor. It just won't. It doesn't factor. Any questions on this here? Any questions on any of this here so far? Okay. Let's look at this one here. So we're going to do the same thing. We're going to show that x minus 2 is a factor. And then once we've shown that it's a factor, then we're going to factor it completely. So across the top, we'd have 1 for x to the 4th, negative 2 for x cubed, 0 for x squared, 1 for x, and negative 2. Drop the 1. Now the number that would go in the cubbyhole would be 2, because if we solved x minus 2 equal to 0, we would add 2 to both sides and see that x is equal to 2 for this here. Now we can multiply, and we would do 2 times 1, which would give us 2. Well, negative 2 plus 2 would be 0. 2 times 0 is 0. 0 plus 0 is 0. 2 times 0 is 0. And 1 plus 0 is 1. Now we have to do 2 times 1. Well, that'll give us 2 again. And negative 2 plus 2 is 0. So it is a factor, and we were able to show that it is by using our synthetic division. Any questions over anything we've done so far? Now what we can do is we can go back in and put in our variables. So our remainder, the number next to it would be the term without x. We have the term with x, the term with x squared, and our term with x cubed. So really what I have left over is x to the 3rd plus 1. Because the x squared term and the x term are both 0, they simplify out because they have 0 in front of them. We don't need them. And our other factor is x minus 2, not plus 2. It's going to be x minus 2. Is this completely factored? Well, no, it is not, because this here is a sum of perfect cubes. Because we can take the cubed root of x to the third and get x. I can take the cubed root of 1 and get 1. This is a sum of perfect cubes. So now that we see that, the next thing we can do is our signs. So it would be the same. So our first one would be plus. Opposite would make it minus. And we always want to end on a positive note. So for this one here, we'd have plus, minus, plus. Now we can plug in our a term, x. Here we'd have x. Here we're going to have x squared, and here we will just have x. Our b term is 1, so in our first set of parentheses, we'd have 1, nothing, 1 to the first, and then 1 squared. Come on. We can simplify this a little bit, so we'd have x plus 2 times x plus 1 times x squared minus x plus 1. And that's it. Questions on this here? Questions on anything we've done so far? Are we good with this here? I think we have one more that we're going to look at. One more on the note sheet? Yes? Okay, this is the last one we'll do for the day, and then we are done with 4.4. So we'll set it up just like we've been doing. So this is going to go in our big, in the space up top, so it would be 1 for x cubed. Then we'd have what? Negative 5 for our x squared. Negative 6 for our x, and then we're done, right? Because I need our constant term, because we need, since it started out with the cubed, we need the cube, the square, the first variable by itself, and then our constant. So we always need everything going all the way down. So since it didn't have a number without a variable, we had to add it in with 0. We're going to drop the 1, and the number that's going to go in the cubby hole would be 6. Would it be positive or negative? Positive. Because when we solved x minus 6 equal to 0, it would become x equals 6. So that's how we know what goes in the cubby hole. Now we can multiply 6 times 1. So 6 times 1 would give me 6. Negative 5 plus 6 would be what? 1, wouldn't it? 6 times 1 is still 6. Negative 6 plus 6 is 6 times 0 is 0. And 0 plus 0 is still 0. Any questions on any of this here? Okay. So no question on any of this here. Let's go on and put the variables back in. Constant, term without x, term with x, term with x squared. So what's left over after when we divide? It would be what? X squared plus, and that's it. We don't have a constant term. We just have this here, yes? Now the other factor that we had would be our x minus 6, yes? Okay. So before we move on to seeing if this is completely factored, are there any questions on how we got to this here? We good with this here? Okay. X minus 6, we know that's completely factored because the degree is 1, the biggest exponent's 1. Is x squared plus x factorable? Well, it's not the difference of perfect cubes because the biggest power we have is 2. That doesn't work. We don't have a constant term, so it's kind of hard to factor it that way, yes? What was the first thing we've done in almost every single time when we try to factor something? What was the first thing we look for? Started with a G. Is there a greatest common factor between these? They share an x, don't they? I can factor that out. So if I factor an x out of this, an x out of x squared leaves me with x. X out of x is plus 1. So I can factor x squared plus x to x times x plus 1 because there's a greatest common factor of x. Yes? And we can put it on the end because really any three things multiplied together are going to be the same. Order doesn't matter for multiplication. So we can move it to the back. And that's it. And we only need it once because it's only coming out of one of the sets of parentheses. But that's it. That's all we have to do for this here. Any questions on this here? Well, that's it.